Here we go with example 5, estimating a population mean. And if you read this question, you'll notice that they want us to estimate the average amount of money spent per week on gasoline for students, and they want us to find a confidence interval for the mean. So there you go. So the words are going to be in different places within the question, but the key words to me there are confidence interval for a mean. So here we go. We will now look at the question. We're going to skim the question and look for those two magic words, standard deviation, and read the sentence that contains those words to see if it's from a population or a sample. Population, you know, the theoretical all students, or a small group of small group of students. So, standard deviation, tunnel vision, standard deviation. Here we go, standard deviation. The standard deviation of the sample. Standard deviation of a sample. Pretty obvious, okay? Standard deviation of a sample. But wait, it says something about a population later on. Yeah, I know. But that standard deviation isn't for that population, it's for the sample. Standard deviation of a sample! Okay, so, sample. Does it say that the population is normally distributed? Let's read the question and see if we see the words normally distributed, shall we? I'll stand right here. You can look at in front of you or over my shoulder. Let's see. A recent study, 25 students, the standard deviation of the sample. Assuming that the population is normally distributed. Population is normally distributed. Did it say that the population is normally distributed? Yes. Yes, it did. Yes, it did. X bar plus or minus T alpha over 2 S over the square root of n. Formula, all right. What is the error that Mr. Standard Deviation sees all the time on a question like this? They only sampled 25 students. That's less than 30. NP, non-parametric, bootstrapping, I'll write that. That never became an issue. That question got bypassed by the fact that they told us it was normally distributed. So the point is, that never became an issue because they told us it was normally distributed. Boom, yes. Is it normally distributed? Yeah, it said so. Yes, here you go. We never had to check the sample size. Okay? So that's why these are in the sequence they are. Put a ton of time into thinking about how to sketch this out so that things would lead you to the right formula. All right? Being told it was normally distributed was a big deal. It didn't matter how many they sampled. Okay? Don't know what else to do there. Okay, so we go back now and we start plugging numbers in. The $52.47 was the average gasoline expenditure for that sample of 25 students. The S would be the standard deviation for that sample, which we were told was $3. I'm just going to put 3 there. I don't need the 0.00. N was the 25 students that were sampled. And again, this is important. We're going to be using the T-table to get our multiplier here that we'll put in. So again, this is just me. When I am doing a T question, I usually exaggerate the picture. It doesn't change the numbers to draw the picture weird. I just do that so that when I'm glancing at my own work, I'll go, oh, I use T on this one. All right, this is my thing. You know, do whatever you want with that. But the two things that need to be identified at this point would be the fact that they want us to use 95% confidence. It says so in the question. And the fact that the degrees of freedom would be the sample size of 25 minus 1, n minus 1, sample size minus 1. They sampled 25 students, and 25 minus 1 is 24. So 95% confidence and 24 degrees of freedom. Confidence intervals, 95%. Looks like it'd be this column right here, wouldn't it? Okay, and then 24 degrees of freedom, right here. And boy, this is hard when you're standing this close. I want to do shadow puppets and stuff. Hello, welcome to statistics. All right, but 24 degrees of freedom and 95% confidence. I hope I see it right. 2.064. So there'd be a 2.064 up here on the plus side and a 2.6064 on the minus side. And the plus and minus are both baked into the formula. And I think you know the drill from here. So then you multiply all that out to get your margin of error and blah, blah, blah. All right? So 2.064 times 3 equals, divided by, I can do the square root of 25 in my head, it's 5. So it looks like the margin of error is about $1.24 roughly. Remember the variable here is money. And then I want to remind you that you get the lower end of your estimate by doing the minus and the upper end by doing the plus. And I think it makes sense in this case to round it to 2 places because once again the variable is money. And so look, I'm going to be lazy, but you have it in front of you. It looks like that 95% confidence interval would be on the low end 51.23 and on the upper end 53.71. Minus to get the smaller number, plus to get the larger, give or take. There you go. All right, so there's a huge amount of reading here. You got to read the problem, pick out the key words. I'm yelling them, I don't know what else to do, but if you don't get to the right formula, so I'm just telling you, when I grade these, the first thing I check, I have a box on the homework, put the formula in the box. I check that first. If you get it right, I keep reading. If you get the wrong formula, the rest of it's all messed up anyway. So getting that right formula is such a big deal. Take your time, read the question carefully. All right, so that's example 5.